students. In this session, we will learn about Kirchhoff's rules. Kirchhoff's rules are very useful for the analysis of electric circuits. There are two rules. The first one is Kirchhoff's first rule and the second one is Kirchhoff's second rule. The first rule is called Kirchhoff's current law. And the second rule is called Kirchhoff's voltage law. Kirchhoff's first rule is also called as junction rule. Another name for Kirchhoff's first rule is junction rule or nodal rule or point rule. According to this junction rule, at any junction, the sum of the currents entering the junction must be equal to the currents leaving the junction. You look at this figure, you can see current I1 and I2 are entering at this node, whereas current I3 and I4 are leaving the node. According to this Kirchhoff's first rule or Kirchhoff's current law, the current entering the node I1 plus I2 must be equal to I3 plus I4, or you can also write I1 plus I2 minus I3 minus I4 is equal to 0. That is sigma I is equal to 0. The algebraic sum of the currents entering a node or a junction is equal to 0. I1 plus I2 is equal to I3 plus I4 from this diagram. That is I1 plus I2 minus I3 minus I4 is equal to 0. Sigma I is equal to 0. The algebraic sum of the current into any junction will be 0 according to this Kirchhoff's current law. It is based on the conservation of charge. Kirchhoff's second rule, or otherwise it is known as Kirchhoff's voltage law, KVL. It is also known as mesh rule or loop rule. According to this Kirchhoff's voltage law, the algebraic sum of all the voltage drops around any closed loop is equal to 0. It is a statement of the law of conservation of energy. This is a closed loop. The battery potential is E and the voltage drop across this resistor is V. According to this second law, E minus V is equal to 0. E minus V is equal to 0 from this circuit diagram. Positive and negative signs in Kirchhoff's voltage law. When you are applying Kirchhoff's voltage law, you should take care of the sign. The sign convention is very important here. When you are considering a resistor, the potential difference delta V between the terminals of the resistor, that is here the terminals are marked as A and B. What will be the potential difference between A and B? That is delta V, which is equal to VB minus VA is equal to minus IR. Take care of this sign. It is always minus IR. Minus sign when it is in the direction of the current. Whereas if the current is in the opposite direction, the potential difference delta V will be positive IR. In case of a resistor of resistance R, potential will decrease in the direction of the current. V is equal to, or delta V is equal to minus IR. When you consider the cell, what will be the EMF of the cell? The potential difference between A and B. these two terminals of the cell. In this cell, this A is negative terminal and B is positive terminal. The potential difference between these two terminals is VB minus VA, which is equal to plus E. From negative to positive, it is negative to positive, it is plus E. Therefore, from positive to negative, it will be minus E. You can easily remember this EMF polarity because low to high is high and high to low is low. That way you can easily remember. When traveling from positive to negative in an EMF source, the voltage drops. So the value is negative. When going from negative to positive, the voltage goes up. So the value is positive. You have to follow these steps to apply the Kirchhoff's law. First, you must choose the loop to apply the Kirchhoff's law. And you can assume any direction. For the current flow, you must choose either the clockwise direction or the anti-clockwise direction. In case of a resistor R, we have seen that the potential will decrease in the direction of the current. Please note this. For an EMF power source, from positive to negative, the voltage drops. Therefore, the value is negative. And from negative to positive, the voltage goes up. So, the value is positive. To understand Kirchhoff's laws, let us look into this example. You can see two loops in this diagram, say loop 1 and loop 2. Loop 1 S1, let it be A, B, C, D, A, and loop 2, let it be A, B, E, F, A. Next step is to assume current directions in these loops. For loop 1, let the assumed current direction be like this, that is in a clockwise direction. For loop 2 also, we can assume in the clockwise direction. You can assume the direction either clockwise or anti-clockwise. It's up to you. Look at this junction A. The current I1 is entering that junction and I2 and I3 are leaving that junction. Then according to Kirchhoff's first law or the current law, you can write I1 is equal to I2 plus I3, or you can write I1 minus I2 minus I3 is equal to 0. First, let us apply Kirchhoff's voltage law to loop 1. Then we will apply Kirchhoff's voltage law to the loop 2. The current flow for the loop 1 will be as shown. And when you consider the point AB, the point AB, you can see a resistor R2 and a cell of EMF E1. What will be the voltage drop across AB, I2, R2 and epsilon 1? What will be the sign of I2, R2? It will be negative. And what will be the sign of epsilon 1? It will be plus epsilon 1. And when the current flows through this resistor R1, the voltage drop across that resistor R1 will be minus I1 R1, which is equal to 0 according to Kirchhoff's voltage law. The assumed current direction in loop 1 is in this way, that is clockwise direction. In our previous slide, we learned about the sign convention. I2 and this assumed current direction are in the same way. Therefore, it is minus I2 R2. When you consider a cell from negative to positive, we must take positive. That is why positive sign for epsilon 1. Also, I1 is in the same direction as this. Therefore, minus I1 R1. We already learned that for a resistor, if the current flows in the same direction, you must put a negative sign. Now consider the loop 2. The current I3 flows in this direction. What is the assumed direction of current flow? The assumed current flow is in the clockwise direction. The current flows clockwise. Let us apply Kirchhoff's voltage law to this loop 2. Minus I3 R3 minus epsilon 2 minus epsilon 1 plus I2 R2 is equal to 0. The voltage drop across R3 is I3 into R3. And what will be the sign? The sign will be negative because the current flow is in this direction, whereas I3 is also in the same direction. Therefore, you must put a negative sign. And when you reach this cell, it is from positive to negative. It is negative. Therefore, you must put negative here. And when it reaches at this point P, then at this point, you can say it is going from positive to negative. Positive to negative is negative minus epsilon 1. And when it reaches here R2, the current I2 is in the opposite direction. Therefore, you must put plus I2 R2. According to first law, I1 minus I2 minus I3 is equal to 0. And applying Kirchhoff's voltage to the closed loop S1, we get minus I2 R2 plus epsilon 1 minus I1 R1 is equal to 0. And for closed loop S2, when you apply Kirchhoff's voltage law, you will get minus I3 R3 minus epsilon 2 minus epsilon 1 plus I2 R2 is equal to 0. If epsilon 1, epsilon 2, R1, R2, R3 values are given, you can find out I1, I2, I3 from these linear equations. When you write down the equations, please take care of the sign. In this example, the starting point for loop 1 is A and the ending point for that loop 1 is also A. Similarly, for loop 2, the starting point was A and the ending point for the loop was A. That is, a closed loop is considered. Say you get a negative value for I3 in this example. What does that mean? It means that the assumed direction of current is wrong. In this session, we learn about Kirchhoff's laws. Kirchhoff has given two rules based on the conservation of electric charge and of energy. The first law, Kirchhoff's current law, is based on the conservation of charge. And the second law, Kirchhoff's voltage law, is based on the conservation of energy. Kirchhoff's current law states that the algebraic sum of the currents into any junction is 0. Whereas Kirchhoff's voltage law states that the algebraic sum of all the voltage drops around any closed loop is 0. We also learn about the sign conventions. While applying Kirchhoff's voltage law, you must take care of the sign. You can choose a direction either clockwise or counterclockwise to go along the loop. Make sure that you are always going in the same direction to determine whether a given element represents an increase or decrease in the voltage. When crossing a resistor, crossing in the same direction as the current means the voltage goes down. So its value is negative. When crossing a resistor in the direction opposite the current, the voltage value is positive. So it is increasing. For an EMF source from positive to negative, the voltage drops. So the value is negative. From negative to positive, the voltage goes up. So the value is positive. Hope you understood Kirchhoff's laws. See you in the next class.